Okay, this is your tabular problem. It's talking about hot water dripping through a coffee maker. It tells you the amount of coffee in ounces for different values of time. Okay, part A, approximate the derivative of C at 3.5. So what I want to do is use the two closest points. So C prime of 3.5 is approximately C of 4 minus C of 3 over 4 minus 3, and those values are 12.8 minus 11.2 over 1, so 1.6 ounces per minute. There's my answer to part A. Part B, is there a time at which C prime of t is equal to 2? You do not know what the exact value of the derivative is and if it's equal to 2, but what you notice is that C of 4 minus C of 2 over 4 minus 2, if you calculate that, it's 12.8 minus 8.8 divided by 2. This is 2. So they told you that C is a differentiable function. So C is differentiable, which it really implies that C is also continuous. And I know by the mean value theorem, if a function is differentiable and continuous, there has to be a place where the average rate of change, which happens to be 2, is also equal to the instantaneous rate of change, which is C prime of 2. So there is a place somewhere between 4 and 2 where this occurs. And I know I use the points from 2 and 4 because that's the interval that they're asking about. Okay, part C, this is your midpoints. Okay, but they want you to come up with an approximation for this integral using a midpoint. So that 1/6 is a constant multiple. I'm going to pull that in the front. The midpoint approximation, I need to use the values in the table, so my first rectangle is going to go from 0 to 2, and the point in the middle is 5.3. So I'm going to use 2, 5.3 as my first rectangle. The next one will start here and go to here, but the point in the middle is 11.2. So 2 times 11.2, same idea for the last one. So this is your midpoint. If I punch this out, it ends up being 10.1 ounces. And the meaning of this is the average amount of coffee in the cup. Always use units in ounces over the time 0 to 6 minutes. Make sure you explain the bounds as well. Lastly, part D, they just want you to come up with the derivative at 5. So if b of t is 16 minus 16 e to the negative 0.4 t, the derivative of this piece becomes 0. Bring down the negative 0.4, which is 6.4. So this is my derivative, and they just want you to plug in 4. So if I plug in 5, you get 6.4 e to the negative 2, and that would be ounces per minute.